Good morning, everyone, and welcome to today's webinar. My name is Emily Kovier-Schall, and I'm part of the BuildUp team. BuildUp is Europe's largest international portal for energy efficiency and renewable energy in buildings. It is a unique community that provides the opportunity to discuss, contribute, and collaborate with other experts in this field. BuildUp aims to bring together stakeholders working in the building sector to reap the collective intelligence about energy reduction in buildings by encouraging knowledge exchange. Our editorial work is organized around the topic of the month, which allows us to dig deeper into specific themes. Each month, several items are produced by BuildUp, such as overview articles and technical articles and infographics. But that's not all. BuildUp also offers the opportunity to host webinars on topics related to energy efficiency and renewable energy in buildings. More recently, BuildUp has offered the opportunity to distinguished experts in the field to share their knowledge in front of our cameras in our BuildUp expert talks. The BuildUp portal shares daily the most relevant events in the field of energy efficiency and renewable energy, but we also participate actively in many European events around the year, such as EPB Center and REBA conferences, H2020 Interreg and cost action events, Covenant of Mayors, and more, with the aim of further disseminating their results and helping to create high-quality media content. The BuildUp portal is updated daily with around 120 new items each month, including events, publications, articles, and video content. But BuildUp is not only us. BuildUp is also a community, and we invite you to be a part of it. By becoming a member, you can contribute by uploading your own content and promoting your news, events, publications, and more. By contributing content, BuildUp will help you to reach a broader audience through our online portal, our social media channels, and our monthly newsletter. Visit us at www.buildup.eu to find out more. It is a pleasure for BuildUp to host today's webinar entitled Data-Driven Innovations for Monitoring the Performance of Buildings, which is organized by two new Horizon Europe projects, DigiBUILD and MODERATE. Both projects are working on data-driven solutions to turn raw data from buildings into meaningful knowledge and improve the interoperability between datasets. We will kick off this webinar with an introduction from SENEA representatives. Then we will hear from both projects and will be provided with an introduction to the innovative solutions that they are working on. Finally, the session will conclude with some roundtable discussions with related projects. In today's agenda, we'll start by hearing from Stavros Stamatakos and Ivan Konachev from SENEA, who will discuss the Horizon Europe call, Need for Advanced Data-Driven Monitoring of Building Stock. Then we'll dive into projects with Christian Potza, Moderate Coordinator and Senior Researcher with the Institute for Renewable Energy at Eurek Research, who will introduce the Moderate project. Philip Mascherbauer, Research Associate at Vienna University of Technology, who will discuss enabling secure and effective data sharing through synthesization techniques. Daniele Antonucci, Senior Researcher with Institute for Renewable Energy at Eurek Research, who will discuss optimizing building performance with data-driven services and the Moderate platform. Then we will hear from Diego Arnone, DigiBUILD Project Coordinator and Senior Researcher at Engineering Ingeniería Informatica, who will introduce the DigiBUILD project. Gianmarco Revel, Professor at Università Politecnica delle Marche, who will present DigiBUILD use cases and technical requirements for smart energy services. Susanna Martin, Head of Energy Efficiency Area at Cartif, who will discuss developing an open, federated, and enriched data lake for building data. And finally, Eliseas Sarmas, Research Associate at National Technical University of Athens, who will discuss a toolbox of AI-based data-driven services for the built environment. These presentations will be followed by a roundtable discussion with speakers and also representatives of related projects, specifically Tassos Titsanis, Business Development Director at Suite 5 Data Intelligence Solutions Limited from Beyond Project, Stoyan Danav, Senior Researcher at CIMNE, and Jordi Carbonell, Researcher at CIMNE from the Big Project, Ulrich Filippi Oberega, Senior Researcher at Eurek Research from Build Hub Project, and also Dario Pellegrino, Researcher at Engineering Ingeniería Informatica from Matrix Project. The roundtable discussions will be moderated by Jesper Fermat, EU Policy and Project Officer. We invite the audience to send us questions through the GoToWebinar platform. Please specify for who or for which project your question is for. There will be 5 minutes after each project presentation for audience questions. We now leave the floor to our first speakers from CINEA, Stavros and Ivan. Thank you very much and enjoy.
Hello, good morning, everyone. I don't know if it's possible to show the slides, Emily. Now, meanwhile, I will try to turn on my camera. Yeah, it's good. Can you please show the slides?
Moment.
Yeah.
Sorry, I apologize for this. One moment.
Excellent, thanks a lot. I think we can go to the next directly. So I'm Stavros from CINEA. I'm a project officer of this very interesting projects that we will hear today, and I will present three topics today. One, I will first of all I will present some use cases that we will all identify with and demonstrate the very relevant and high need for data that we have. Secondly, I will present you what we are doing from the policy side on capturing the data and making them more available to all players. And third, I will shortly present what we are doing on the research and innovation front and what are our expectations from the projects that we are funding from CINEA. So, starting with the first point, if we can go to the next slide, please. I think that most of you will identify with most of the use cases that you will see in the next slide. Thank you very much. You are all living in a house, in a building. You are either as an owner or a tenant, and at some point you will have to make a decision what you can do to improve the energy performance of your building. And there you will identify a performance gap between what is potentially shown on the energy performance certificate, which is a tool that we have put in place at the European Commission, at the European level. It is implemented across all member states. It is the best that we can have. It's very good, but still it's not fully operational. So what we get in an energy performance certificate is an asset rating of your building and does not take into account the usage of the building, so the decisions of the owner. And this is a very important question that we need to solve here. And the same for your technical building systems. You know that we have put in place a number of policy measures like the eco design as an effective tool to improve the environmental performance of products and the way that they are designed and manufactured. And the energy label, you have all happened to buy a new boiler or a new dishwasher or any other appliance, and that you have been looking at the label of the product. But still, what if you need to compare between two different technologies? Am I going to install a boiler, a condensation boiler, or a heat pump? Is it worth the investment to couple my heat pump with a solar system, with battery or without battery? So these are all decisions that they need to be based on actual data, and we all confront with these questions every day, and we all need access to actual data for these cases. The same if you're an engineer or a contractor and you need to make a decision for your client on which decision, which technology to implement, either in a new building or in a renovation building. And the same if you need to measure the performance of your investment. For example, you changed to a new heating system, or you change to a heat pump, and then you need to monitor the post-renovation performance of your system. All these are decisions to be based on data. And is it all about data? No, of course, there are many more decisions about aesthetics, about comfort that come into the equation, but still data are very, very important for our daily decisions. And if we look at it from a financial institution as well, we should all agree that energy efficiency has not been a very, let's say, sexy investment for the financial institutions. They could not, usually the projects are very small, very fragmented, not easily monitor the post-renovation, so not very attractive for financial institutions, which works the other way around as well, not very easy to access from the consumer point of view. So if we don't have the financing, if we don't have the post-renovation monitoring, how can we expect that we can achieve the renovation levels that we aim for? So indeed, data are very, very important factors in this decision making. If we can move on the next slide, I will. The same decisions can when we look at buildings, not at building level, but at the building portfolio level. Can we change, please, Emily? Thank you. So again, you're a facility manager and you're managing a set of buildings, for example, or different assets in buildings, some chillers, some heat pumps. Then, of course, we have the traditional building management systems that are connected to certain devices, but up to now, they have been working one way, so they would give us information on the operational information of the way these assets are operating. But now, building management systems are connected to a variety of devices, such as sensors, actuators, dedicated networks, and their objective is not only observe the state of these assets, but also apply certain rules to preserve or increase the comfort while saving energy. So the stakes are higher for building management systems. Analyzing energy consumption is not the only question now. Many more parameters come into the decision making, such as predicting energy demand and consumption, analyzing building infrastructure, fault detection, prevention, identifying energy metering failures, water management, indoor environmental quality. So all these parameters are being measured by different assets, and data are produced. And the question is, how do you create value out of this data? The same if you're an aggregator and you want to offer flexibility services to the grid, so offering services both to the grid and to the consumers. And I will not go into the detail. Again, if you're a district heating and cooling operator, it's a very difficult problem to design, and very complex and multidimensional problem to design and optimize a new network, considering the different temperature flows in a common network, serving different buildings of different insulation, different quality, and different heating needs. And I will go to the next slide, where we can see the even bigger picture at national or even at EU level, that you want to manage not buildings and not sets of buildings, but the building stock. So you're a national government and you want to design a new subsidy program. You need to have very good knowledge of the state of your buildings. You need to know how many buildings you have in a certain range, category. As I said, we have the energy performance certificates, but then again, they don't take into account the operational data. So you, as a national government, you might need to impact, for example, to monitor the impact of a national legislation, or a subsidy scheme. So you gave an X amount of euros to renovate the buildings, and you have to measure the savings that you have achieved. This should all be based on data, so that we can measure, monitor the result of our actions, and improve our actions for the next time. And if you look at the buildings from the even bigger picture at EU level, we are designing a new EU legislation. As you know, the European Commission is currently proposing a revision of the energy performance of building directive that has certain assumptions of so many numbers of buildings are for example, in the G category and need to be upgraded to an F category in the next 5 years. But these are pure assumptions. They're based on modeling, while the information is out there and they could be based on actual data. And these are only a few use cases that I have presented today. There's many more, like developers, designers, engineers, architects, researchers, the Eurostat and other agencies that they need to tap at this great amount of data that are produced every day from our buildings. They're out there, but they need to be homogenized, brought together, and offered as a service and as an added value to all these players. So with that, if we can go to the next slide, please. I would like to present you what we are doing on the policy side, at least. As I said before, this week, 2 days ago, the recast EPBD was voted at the European Parliament. It's not finished yet. Some last-minute negotiation will still take place in the next months, but it's there and it should be applicable. And there are 2 new articles that I would like to present to you today, very related to data. One is Article 14 on data exchange, that member states should ensure that building owners, tenants, and managers they have direct access to their building systems data. This is very important because they will know exactly the operational data of their technical building systems, which are the main energy consumers of their buildings. This is a very, very important provision, and at the request of the owners or the tenants, this data can be available to a third party. And this is also very important because third parties are these that will provide services on top of this data, be it an aggregator, an ESCO, DSO, etc. And another provision is that member states should facilitate interoperability of these databases with other data platforms in the Union. And a very important provision is that no additional cost should be charged to the building owners, tenants, or managers for access to this data. So these are data offered for free and should be part of the national legislation very, very soon, as long as the EPBD is adopted. And of course, member states can set relevant charges for access to data, but only for the third parties, not for the actual owners of the data, who are the building owners, tenants, or managers. So this is one important article that will come into effect very soon. And if we can move to the next slide, I would like to make a short reference on the Article 19 on the databases for energy performance of buildings. You know that some member states, they use databases for EPCs, but not all, and not all are available. So with this new article, each member state should set up a national database for energy performance certificates that allows data to be gathered, and all the data that come with the EPC should also be available. So not only the energy class and the recommendation of the energy expert, but also the data that were considered for the issuing of this EPC. This is very, very important because these databases are a source of valuable information for policy making, of course, for the market, purposes for owners and tenants, but also for policy making and for research purposes. And I guess you're already very well aware that many of these databases are either closed or non-existent. So with this new provision, they become obligatory and with an obligation to be publicly accessible. So this is another important provision. And then if we can move to the next slide, please. There is an action plan on the digitalizing the energy system that comes with three concrete actions to say related to data. One is the creation of and the deployment of a common EU energy data space. This is not only referred to buildings, but all data produced and relevant to energy players. But there are 3 points there, and maybe the first and the third are very relevant to buildings. One is the interoperability, the flexibility that the energy systems and the interaction that we'll have with the buildings. So the buildings are seen as active nodes of the energy system, able, and they should be able to provide services or even energy in terms of efficiency through demand response schemes. So they can be considered as energy suppliers. And in the last point, in the third point, you can see that the smart and energy efficient buildings, they can capitalize on data produced by all these sensors to provide, to promote and finance energy efficient building renovations. So as you can see, buildings are very important in 2 out of 3 action points under this common EU energy data space, and I invite you to follow closely because this is in the making, and it will be very, very important area in the next years. As a second step, the European Commission will adopt 2 implementing acts. One is on interoperability requirements for access to metering and consumption data. This is also very important because these are the actual and operational data that I referred at the beginning of this presentation that should be very, very relevant to all the players. And the other is an implementing act on interoperability requirements for access to data required for demand response and customer switching. So this will become part of the EU legislation as well, these interoperability standards. And the third block, which is recognized under the digitalization action plan, is the continuous support to research and innovation and the pilot deployment of data exchange frameworks. And with this point, I come to the third part of my presentation, what we're doing in the front of research. So if we can go to the next slide, please. You can, as you're all aware, the cluster 5 is built along 6 different destinations that we focus. Our small team focuses on destination 4, which is the demand side of energy and the buildings and industry. And as again, if we can go to the next slide, please. In the center of our attention are not only buildings. Of course, we do many more things with buildings, but smart buildings are an essential element in the decarbonized, renewable, intensive, and integrated energy system. So our objectives are 3: to achieve high energy efficiency by optimal operation. Second is to strengthen the role of demand-side flexibility. And third is to ensure that building user needs are covered. And if we can move to the last slide, our policy, or let's say our funding around smart buildings is covered in 4 general building blocks, as you can say. One is on the upgrade of smartness of existing buildings. We have had a call on 2019 with 5 projects currently still running, and a call on 2020 with 4 funded projects that they are running. And we also had a call on 2022. The projects are not started yet. They are under evaluation. I think 2 projects were selected from there. The second building block is the next generation of energy performance certificates. You know that there is a big need to intensify the efforts of the energy performance certificates to close the performance gap and make them as close as possible to actual operational data. So we have 6 projects in total running on this field. And the third block is around the buildings data. You know very well the area. I don't go into that because all projects, I think, they're present in this meeting. But maybe it's interesting to let you know that we have a 4th block of projects that is starting now. So from the call of 2022, we have already selected 2 projects that they are in grant agreement preparation, and 2 more projects will be selected later this year to start by the end of the year. So we will have, by the end of the year, we will have 4 projects working on demand response. I would like to close with this. It's let's say the ball now is on you. You know the needs of the market. The market is out there. The players are really eager to tap on this untapped data potential, and I'm sure that you're doing an excellent job on bringing this data together and giving them the value that all the players of the buildings industry need in order to achieve the decarbonized building stock. Thank you very much for organizing this webinar. We are supporting the project as much as possible from CINEA side. You can contact us in all these links. But also me personally, you know me, I follow very closely your projects, and I will stay here for the rest of the webinar to hear what you have achieved so far. Thanks a lot.
Thank you, Stavros. Okay, we will move to our next presentation. Okay, Christian, you have the floor.
Yeah, thank you. Good morning to all. I will quickly introduce the project, MODERATE, and then in the remaining 2 presentations by my colleagues, we will go through some details. So, why MODERATE? Which is the reason why we proposed to go on with this project to CINEA. Is because we found and there are needs from the market mainly to get access to data, as Stavros was mentioning, but also to get access correctly to those data. Now the new EPBD is going to support more this access to data, but accessing data is not enough. We need also to understand which is the quality, which is the meaning of data, which is the knowledge that is behind. So we need, and the market needs suitable methods and also infrastructure for sharing that data. And also, despite there have been much push towards standardization and interoperability, also by other projects that we will hear later today, there is still a need for standardization and interoperability because most of the standards are not covering all the type of data that are from building. And then there is a need to get complete, trusted, and high-quality data set to also to start thinking to new services or to that can be provided to buildings. And also services that are now the state of the art have been thought or trained with a limited number of data or data sets because they were not available or various enough. And so we also need to improve reliability of services given that we can provide much more data. So this is why we proposed Moderate as a project. And so the goals are to develop functionalities and services that can enable or collection of data and to transform that data sets that are the collected from the field, from different sources, into one source of knowledge and ideally wisdom for the users. So that said, there is still the need to match data providers with data consumers. So our approach is more focusing on sharing knowledge than the raw data set. So we prepare data so that they contain knowledge, but not so specific to some building, because there are a lot of issues also relating to identification of certain characteristics of the building, of the users, of those buildings. So there are also ethical issues underneath. So we need to match data providers and consumers, but in the correct way. And again, the goal is to share high quality data sets that are open data sets and also services which can be openly shared and used as templates by others. And we want to do that in compliance with ethical and law constraints. Ethics in AI, for example, is an emerging field. So we are also inclusive with external stakeholders that want to cooperate on this side. So what the project is going to produce is a set of open data sets that will reflect ethical and fair principles, and will be available. They are synthetic, so it means that they are not the original data, but it's a synthetic version which is enriched. We will see later a presentation on that for details. But this is the added value in particular. And then the data-driven analytics tools are being co-designed and demonstrated on real workflows during the project. So they grow because of final user needs. We target most of the target users that Stavros was mentioned earlier, and they rely on the synthetic data sets, so on the knowledge that we extract from different sources, and based on that, we expect that services can improve, and also they will be open and shareable. And then we need a secure and compliant, also legally compliant data sharing mechanism which allow to share data correctly, and also to get to provide a correct value to that data. Some data, of course, most of data hopefully will be open data set, but there are certain data that might be shared anyway. Also, the new activity is introducing this concept, so that then can be a payment for accessing to data, which has to be fair, of course, but there is potentially a business model around that. So the innovation that we introduce with our project is the first is we improve data collection, and we will see just a few details. So first data collection, then data synthesization, and then we harmonize and standardize data. We cooperate with others, and as it is a very open initiative, first with DigiBuild project, for example. And then we focus on analytics and in the marketplace. So these are the main innovation that we are bringing with this project. In particular, the data collection methods are improved because we are trying to merge information which is typically bottom-up, like information on EPC data, building use type information with satellite data, topography, information on climate, population. We also merge dynamic data like monitoring or information on bills or maintenance, faults, things like that, because we know that they will be increasingly available in the future from many buildings across Europe, but so far right now they are not. So the information that you can get is very jeopardized and incomplete most of the time. So where we add value is to create a method that can complete information with reliable information that can be likely correct. And then, of course, this information will be refined. So we end up with complete datasets, high quality datasets of that can be synthesized and also standardized, meaning that we can add information from different sources to make them more complete. We can remove biases, for example, or increase the quality, or change the frequency of datasets, or distribute models that can generate datasets. And also, datasets are coherent from the different point of view, like energy consumption and load profiles, or if we look at spatial distribution and sometimes serious data like monitoring, realistic monitoring profiles from certain regions or certain areas. And also we can work on different level of data aggregation to support, for example, what happens for the policymakers. And then again, standardization and harmonization of different data type, but in particular of energy performance data, are very important. For example, one application we are thinking at is the quality checking of the EPC data, but also we are developing some functionalities that can be used for other purposes, like geospatial clustering. Like if you need to group by non-trivial similarities the different buildings, you would be able to do that. Then also benchmarking. It's much easier if you can benchmark towards realistic buildings that can be made by this synthetic approach. You can compare characteristics and trends, and also other helper tools and APIs for data collection and standardization will be available on the marketplace. So quickly go on analytics. We will see later basically of three types for system management, building optimization and assessment, and also decision making like planning and de-risking energy efficiency upgrades. And then the last innovation is open data sets will be available, like also open source services and the software pipelines that can do quality checks and other aspects on this data. The marketplace will be first a virtual laboratory, so that also other projects, for example, can test before investing in services. This is also helpful for SMEs that will find open data and services on the same place and free that can access them to the code for testing and checking what happens for their business. And also we can of course support for more advanced use of data, knowledge, and related services. We target the stakeholders. There are also B2B companies emerging, but also Stavros touched that point. We cooperate with other initiatives, open source community, European Digital Innovation Hub Network, and others. So this is, I can skip because we are a bit late on the roadmap. But yeah, this is our project team, and I just introduce you. If I can. Thank you for that. I leave the word to Philip Maschabauer to intervene on data synthesization. Thank you.
Thanks, Christian, for the introduction. Yes, I will talk now about data synthesization, specifically for load profiles with neural networks within the MODERATE project. The content of my presentation will be the following. First, I will go shortly over the GDPR background, then what is synthetic data and why we use synthetic data, and then how finally we're going to create the synthetic data, the workflow, and then specifically I will go into the GAN and sum up with the conclusion. So GDPR is the General Data Protection Regulation. It is a European regulation that was adopted in 2018, and it sets out the rules on how personal data can be collected, used, stored, and shared. And data is usually GDPR compliant if no personal information can be inferred from the data, because as soon as personal information is out of the data, GDPR doesn't comply anymore. So what this means for our data is that sometimes anonymizing the data is not enough. For example, when we have some load profiles from smart meter data, for example, just by the shape of the profiles, even if we don't know who the profiles belong to and where they are from, or not exactly the location, we can sometimes identify from the shape of the profiles if this profile belongs to a certain building or maybe a market, some industry whatsoever, and then we would have identified a single entity, and therefore we are not GDPR compliant anymore. So to overcome this problem, we are going to use synthetic data. Synthetic data is artificially generated data that mimics the real data because the underlying statistical properties are very similar, and at the same time we are masking sensitive information because the synthetic data itself can, after synthesization, it cannot be assigned to any single person or household entity whatsoever. This is also one of the big advantages of synthetic data because you automatically comply with privacy and confidentiality agreements. You're able to share your data, and in addition, the quality of synthetic data is usually or is very high because you don't have any outliers, you don't have missing values. It is highly scalable. You can produce as much as you need, and yeah, this is one of the biggest advantages over real data because real data is often very rare and hard to get. On the contrary, the quality of the synthetic data depends highly on the raw data itself and on the model that you're using to create it. The computational resources are relatively high, and you always need an expert who fine-tunes the model to make the synthetic data useful for the specific use case and checks if the synthetic data is viable. So the precise control of the algorithm can be challenging. Here on the left, we see usually that sensitive data has the highest value. And again, when we classically anonymize the data, we lose a lot of this value because for coming back to the load profiles, we don't know where the load profile came from, if this is a residential building load profile or a market, whatever. But with synthetic data, we keep most of this value because we can create, for example, a load profile from a single family house with 4 residents, and then we have a very specific load profile for a specific reason, and with but still it cannot be trace back to any person. The synthetic data that will be included from our side in the moderate platform will include the EPC data, for example, as I said, load profiles, electricity load profiles, so smart meter data, heating profiles, and sensor data, so any measured data from stores, for example, temperature data, temperature sensors, and so on. And now the added value of moderate is because you might say, okay, synthetic data is good and all, but many people already use synthetic data, especially for machine learning possibilities. However, if you want to get synthetic data for a specific reason, for buildings, for example, you have to find it from a certain source. Often it is not available. The data is different depending on the source, and also the data is rarely complete. And with moderate, we're trying to get these problems. You will be able to generate an enriched data set, which is merged by different data sources. So the data set will not rely only on a single source. It will be realistic and have consistent properties across different aspects. And also it is standardized in an interoperable way, so you don't have to worry about having different data sets that you need to merge somehow. And this will also, you might be able to avoid the use of other tools, like for heating profiles, for example. You don't need to simulate single buildings anymore with some third software. Now, for load profiles specifically, we investigated two main approaches. One of them is the variational autoencoder, which deals very well when training the model with missing data, and the generative adversarial networks, also called GANs. And they are known to be very good at creating high quality synthetic load profiles. So we decided to go with GANs. I will shortly go over the workflow. We will collect the raw smart meter data, pre-process it, and then cluster load profiles. We realized that when we want to train a neural network, that we need to cluster similar profiles together. Otherwise, for training, if we merge two divergent profiles, then the algorithm will not work as well. So we cluster the profiles, then we train our models, and finally generate the load profiles. Just a very basic overview of how this GAN works. We have two, you can see my mouse. You have two neural networks. One is called the generator and one is the discriminator. Into the generator, we feed random data points. You can see here on the right side, these might be the randomized data points that are fed in. And the generator tries to generate a fake load profile that is as close as possible to the real profile. And the discriminator, on the other hand, tries to say if this profile is real or fake. So it tries to distinguish the profile that has been generated and label is it real and fake. And then in a loop, these two models train themselves. So the generator tries to get better and better at creating fake load profiles, and the discriminator at the same time gets better and better in distinguishing the load profiles from each other. And when the training is done, the generator will finally be able to create really real load profiles. We can see here on the top, this is a very basic example. In the beginning, we have only some random data points, and when the training is done, this profile now here is like a sine curve as an example of how this basically works. If you have any more questions on the specific network we're going to use or planning to use, please ask me in the chat. Afterwards, I will try to reply to all your questions. So to sum this up at the end, one of our goals with the moderate platform is that anyone is able to transfer their own data into synthetic data, to be able to openly share the data for any kind of reasons, training teams running audits, or even provide subcontractors with data. and also to exploit your own data together with openly shared data from other sources. So if you have data only from your country, you might want to have data from another country for comparison, whatever. This is what we're trying to achieve with this project. And with that, I'm already finished with my presentation. Thank you very much for your attention. And I will hand over to my colleague, Daniele Antonucci from Europe.
Okay, good morning to all. Okay. So, sorry. So today I'm going to, I'm Daniele Antonucci, and I'm a senior researcher at the Europe Research Centers, and I'm going to provide some information about the moderate platform and the data-driven service. I try to be as fast as possible due to the fact that we are slightly in delay. So the content of this presentation will be so some information on the moderate platform, the data-driven service, and how we try to tackle the part 22 from data to market. The moderate platform as generally the platform that use data, try to connect a lot of data with some services. So it is the one of the normal aim of the data platform. Moreover, we try to add much more feature on this. One of these is the marketplace. So meaning that, as also Christian said, that if you are an owner of data, you can use our platform on both for use the services that you are going to develop, but also if there is someone interested in your data, you can sell your data. So there will be the connection between the data provider and data buyer. Considering the platform is divided in three main layers. So we have a first layer in which there is we call it data producer, in which we are going to collect all the data coming from the different sources. So that could be open data, but also private data. In this case, for the private data, as Philip said, so there are sometimes there is some issue related to the privacy. So this is why we decide to apply a synthesization algorithm that is much more better comparing to the normal aggregation and normalization of data, due to the fact that we are not going to lose some statistical pattern on the dataset. All this data we try to connect together to increase the knowledge inside from the dataset, and after there is a platform that ingests this data. So there will be a storage layer and processing layer that can provide all the information to the analytics. Between the storage and the analytics, we have also a trust layer based on IoT technologies that provide information and also give you a reliability about all the flux and the path that the flux of data. So I want to say that this platform, our idea is to create everything open. So not all, of course, not the part related to the data, but the code that is related to the platform, and also in particular the part related to the analytics will be open. In particular, as you can see here, we have three main parts. So on one end, we have the user that are not only data producer, but also the platform user. So at the end, they provide the data, and after they receive back from the services some information and knowledge, then can use it. There is the platform, and after there are the services. The services, as I said before, will be totally open in a way that the user can take also part of the code that using his business, or try to modify by itself. We have different industrial partners already working on the project, but of course we are searching for everything for order. And for the part related to the analytics, we have three main topics: the moderate system management, the moderate optimization and building assessment, and after the decision making. All of them are based on specific KPIs, key performance indicators, and market readiness indicators. So before to start the development of the tool, we then identify which are the KPIs and SRI that can be used by each single service. For the system management, we have three main analytics that deals mainly on systems, so fault detection, energy system, and energy conservation measure. For this latter cover not only the part of the system, but also the part related to the building refurbishment, so the facade part. We have a part related to the building optimization and assessment. So in this case, there are 4 main services related to the solar cadastre and local energy communities. These 2 services work mainly together. And after partly to the assessment of the refurbishment of the building using a measure and verification approach, and after the benchmarking tool. At the end, we have a moderate that is related to the policy making. In this case, we try to identify some tool for the de-risking energy efficiency, APC harmonization. This one is one of the hype topic that we're trying to face. And the last one will be the geoclustering tool. That is a tool that try to identify some similarity between buildings in georeferenced area. Considering the services, we'll just provide for each single area some details of some services. The first one is related to fault detection forecasting. In this case, we have a partner that is Synavision, that is a partner that is already working on this topic, and this business is on this area. And the tool that they have is a tool that is already proven in the market. So what we're trying to do is to try to get some features that coming from this tool to give this feature available to the moderate user, and increase also the skills that are available in this platform. The platform is able to forecast the energy consumption of some systems, and also identify if there are some fault on the system, and also provide some statistical analysis and pre-processing of data coming from different type of systems. The second one is for the decision making. So in this case, we have the APC. APC is it's a topic in which there are a lot of difference calculation made to make the calculation of the APC generally change from region, from country to country, from region in a specific country, and also sometimes it's difficult to compare the APC together. What we try to do together with a partner that we have inside the consortium is focalizing, in this case we focalize on the Spain country, collecting information about different type of APC, and identify the first things we want to identify the quality check. So because it's one of the issue that the APC generally have is the quality and the reliability of the data. And after identify which could be the possible normalization between this APC, as I said before, starting on the different region on Spain, and after move on a large case, it then provides a benchmarking report and an APC calibration. The other services that are representative of the building optimization assessment that I'm going to show you is the local energy community assessment tool. So we found out that there is there is no specific tool working on assessment of the tool. In particular, we have a partner that is trying to understand which could be an utility company, trying to understand which could be the area in which define local energy communities. This is why we are going to develop this specific tool that take into account different type of data sets. So try to combine data set coming from cadastral data, solar cadastral data, energy data, socioeconomic data, or also PV potential. In this case, it's connected to the solar cadastre. So all this information will be connected together with a specific machine learning algorithm that generate the models. These models will be applied on a specific area to try to understand if this area is able to be local energy communities or not. As I said before, this one is now under development, in particular in an area located to the Valencia region. So related to data enhancement. So I mean, in moderate, one of the future, or the important future, is the connection between open data and private data. The private data, as I said before, is not possible to share as it is. So this is why we moved to the synthetic data. What we are trying to do is to combine together different datasets, so the open and the synthetic ones, in a way that can improve the knowledge and insight from the data. One of the samples could be taken in consideration the data coming from the cadastral data, and on the other hand, the energy consumption coming from the utility company. So the joining these two data can provide much more information that can be used by different services and can generate, as before, much more knowledge, comparing only to use the dataset separately, or only aggregated and anonymized data. So starting from the last one, just a recap about our work. So we want to start and to collaborate with different type of stakeholders on buildings. So investor, building stakeholders, small medium enterprise project that can be user of the platform and data provider, and combine this information with also actors that works mainly on the knowledge part, so research, developer, and data scientists. They can provide data and knowledge that can be processed by the moderate platform, and after, as I said before, we are going to put a trust layer that validate all the process and the reliability of the data. And after, we have our moderate platform. The platform is totally will be open, not for the party to the data, but for the other part will be open and data shared in GitHub repository. And after, we have the services. For the services, I want to say that we trying to make the connection between the services and to have all the services connected together. So I mean, the output of some services can be also the input of the other services. So we don't want to have services that work separately. So they are standalone services, but they are connected all together. And also the choice of the services and that we define is based only on this connection between the different services. As I said, all the code that will be open source and can be reusable, and making also our idea to have an open community, and a community that can work on the on the moderate platform, due to the fact that we provide everything in an open way. So thank you so much for. I leave the floor.
Yes. Considering that we're running behind schedule, I would encourage all attendees who have questions to directly address their questions in the chat to the speakers, because we have to move on. And we're going to now go to the next set of presentations, which is introducing DigiBUILD. The first speaker will be Diego Arnone, the coordinator of DigiBUILD, and as a part of a senior researcher at engineering. Diego, I'll leave the floor to you.
Okay, good morning. Can you hear me?
Yes, we can hear you perfectly.
Okay, thank you. Thank you to all the organizers. Thank you to our colleagues from Moderate. Thank you to the project officer that is taking part very kindly to this webinar. I will give you a very short introduction to the DigiBUILD project, and then I will give the floor to my colleagues that will go more in depth in some of the results already achieved in the first 9-10 months of the project. So very quickly, the identity card of the project, just a few numbers and references about the call, about the extended title of the project, the numbers concerning the costs, the EU contribution, and the number of partners. So we have 17 partners from 11 countries. You can see the map and the distribution on European area of the different partners. And among these partners, engineering is the ICT company, the large ICT company that coordinates the project. And we have 9 different stakeholders from the building life cycle. We have 4 important academic institutions and research centers and other key partners like CWare, IECP, and Power. So very briefly, the vision and approach of our project. We saw this morning the strategies and the policies coming from the European Commission. Previously, DigiBuild is perfectly in line with some of them, with most of them. The idea is to contribute to the development of an energy efficient building data space. We are adopting, just in the first month of the project, we have already started to adopt them. Some results are already available in terms of user requirements. We are adopting the co-creation methodologies according to the European House Initiative. The idea is to collect and manage data in order to drive more robust, improved and consistent monitoring of building stock energy performance. So, which are the objectives? In a nutshell, we can say that, as I mentioned before, we will leverage on the European Bauhaus initiative. We aim to demonstrate how data models and analytic services in the building sector can offer tangible, positive experience in our daily life. Then a federated data lake will be is being created to improve the different data quality dimensions in terms of completeness, reliability, accessibility, interoperability, and so on. The idea is to merge multiple heterogeneous data from buildings and adopting business intelligence analytics through the concept of data marts. So the third objective can be considered as the encouragement for the development of the data space. So the idea is to translate the cross-sector international data space architecture into Gaia-X technological connectors. Concerning the interoperability, okay, 3 levels of interoperability: southbound, northbound, and semantic interoperability that we will see in one of the next presentation will be reached by leveraging and harmonizing several ongoing semantic interoperability and standardization efforts. DigiBuild will also deploy services based on artificial intelligence tools for high-quality data-driven energy management for energy-efficient buildings based on static and dynamic data and enriched with semantic information. DigiBuild will deploy digital building twins as a common semantic data representation by combining static and dynamic data, defining and aggregating metadata to and from physical assets. So the aim is to support the design, construction, operation and maintenance, refurbishment, decommissioning phases, so the entire lifetime of a building. Then I put here the objective number 8 because the 7th is in the next slides. The project will define all the stakeholders, will define new business models, will validate these business models, and also we can say that the project will carefully design and plan dissemination, communication, industrial clustering activities. Last but absolutely not least is the objective number 7, because it's about demonstration. We have 9 pilots that have been clustered in 3 main groups. So these 9 pilots are very relevant if we compare these clusters to what Stavros showed at the beginning of this webinar, when he mentioned that if I'm the owner, if I'm the contractor, if I'm the financial institution. So basically we map some of our pilots to different categories that are relevant for providing an answer to that question. So the pilot cluster number 1, buildings performance. So we have services and business models for proactive facility management, retrofitting old building and deep energy renovation. The cluster number 2 is building versus infrastructure optimal management. So services and business models for improving data quality and analytics and thermal networks, electric vehicle fleet, smart charging management, to increase the office building efficiency, and design future buildings and building processes and industrial area, carbon-free buildings with flexible assets. So this is the second cluster. And the third one is about the services and business models for climate resilient buildings, pay for comfort schemes, and financing energy efficiency in buildings. So this is the last slide that mainly report about the 3 different clusters and the pilots belonging to these clusters distributed all over the European area. So we can see the ones belonging to the buildings performance, the ones belonging to buildings versus infrastructure optimal management, and the ones related to policy and finance. So we can say that probably not only the development of a data lake, the contribution to the energy efficient building data space, but and also the analytic services that are being developed based on innovative AI algorithms and tools, but also the availability of the relevant amount of real data coming from different pilots all over Europe. So I think that is one of the most important thing of our project. So that's all from my side. So I give the floor to my colleagues since they will provide the further information about the main achievements and this first part of the project. Thank you.
Hello, good morning. This is Gianmarco Revel from Università Politecnica delle Marche, and I'm going to give a short presentation which includes mainly topics related to use cases and technical requirements for the services that the DigiBUILD project is developing. We will go through the methodology that has been already implemented in the first months of the project, and then I will just bring one example which is related to the services focused on comfort and well-being related to a specific pilot case that I will use just as an example to show how what we are trying to do is, as Stavros was underlying in the beginning, is to give value to data through the deployment of innovative services and high performance services. So basically, very short presentation about our group. We are from Università Politecnica delle Marche, which is a high-tech university in Italy. We are a group focused on development of sensors and measurement techniques and data-based services based on the data we measure, and we have a large focus on buildings related services, buildings and cities related services. So basically, as already Diego was describing, within the framework of the global DigiBUILD goal, which is to develop an open, interoperable, and cloud-based toolbox to shift from a silo approach in buildings management into giving value to data into an interoperable and smarter framework. Basically, we are developing, we are targeting a certain number of high-quality data-driven services, which are mainly interoperability and high-quality data, energy profiling and forecasting, energy resources and management, enhanced comfort and well-being, road mapping and energy efficiency financing, efficient and climate resilient buildings, designing future buildings and processes, planning of building infrastructures, and district scale management and operations. So basically, these are related to also to the 3 pilot clusters that Diego presented before, going, of course, more into the details of the offered services based on the high quality data. So the methodology that has been implemented is, of course, based on defining use cases, and on the base of the use cases, defining technical requirements. This is a very important step, as was already mentioned, because of course it has to take into account the different stakeholders, the different skills of the involved stakeholders, the different requirements. So as all we know, the data has to be managed differently for the different stakeholders and the different purposes. So starting from the pilots, which are representative of a wide set of applications, we performed a first identification of the stakeholders, and then for each stakeholder's identification of the user needs based on several interviews within the different pilots. And based on that, we defined user stories as the first results. From user stories, which are quite qualitative, we go more into user requirements. And this was done as well with a co-creation approach involving all the previous identified stakeholders, and trying to feed these workshops with also technical information from the technical partners. So these 9 workshops, which were held, allowed direct interaction between technical and scientific partners and developers and the stakeholders in the pilot. And there we went more into detailed questions for the different stakeholders, and we were able to also explain, and this was a very important part, better the importance of the digitalized database services for them. From these technical requirements and specifically then use cases will be derived, which will be then, of course, tested in the second part of the project within the 9 pilots that have been previously identified. So this has been the approach that we implemented step by step within the first months of the project. And this is going a little bit under a different perspective through the same process. So we went through the co-creation approach, and then from the co-creation approach, we went into more technical and scientific specifications, which addresses not only which are the data management strategies, data quality monitoring and improvement and so on, but also a little bit targeting the hardware related issue, like for example sensors installation where needed, which are the available data, the available installations, the available devices and services already. And of course, these allow to, as an output, to have digitalized services for buildings, basically developed in a modular approach, because of course the new services has to fit into already the existing service and data structures that are available in the different pilots. And this, of course, it will be a key issue for exploitation as well in the future. So basically, I will just give an example to give concrete explanation of what I'm referring to, describing very quickly I will not go into the details, you of course to time constraint, about the comfort and well-being services that are in particular our focus at Università Politecnica delle Marche. We are involved in these services since many years. So we identified two main areas. The first one is to deliver comfort and well-being to occupants of the building. And the second one is to enhance traditional energy performance contract into comfort performance contract. So making once that comfort can be quantified, can be measured in a quantitative way, so not only temperature, but giving really a multidimensional comfort definition and quantification, we can make this a contractual issue, so we can sell comfort through the services. And this, of course, is very much based on data. So the first one is more how to guarantee everybody in the building that the comfort is provided from the management point of view. The second one is how to make this a contractual framework. So basically, I will very quickly go through one example of pilot where these two services will be implemented. And as I said, we started from identifying the stakeholders. This pilot is the Foki. Foki is a company who is partner of the project and is a company producing curtain walls, facades, and is applying in their own facility, both offices and the manufacturing areas, the comfort services for the occupants, which in this case are, of course, the employees of the company. So we identified the stakeholders. We had several discussions and interviews with them, facility manager, sustainability manager, human resources. So of course, they all of them have different views, different skills, and different requirements. So from those interviews, we identified which are the main requirements, and from those requirements, we went more into technical analysis of what has been already available in the company in terms of data and installations, renewables, controls, and in this case, for example, there are smart facades applied and developed and applied, so already with the smart functionalities, automation functionalities and regulation. And so basically, as I was trying to highlight before, the new services will have to fit into already the existing structure of the data of the company. So from these interviews and this preliminary analysis, of course, a baseline will be shortly derived of the situation. And from these use cases related to first thermal comfort and energy consumption monitoring through the DigiBUILD platform and with all the different flows, and secondly, the management of energy costs to guarantee occupants' comfort and well-being. So going more into the contractual side related to expenses and costs to provide the services have been step by step analyzed, developed up to the configuration of the dashboard, of the different functionalities provided, how to access the services, and so on. So this is just an example on how we went through the use stories, then the user requirements, which ended up then with technical requirements for each of the services and for what will be in future developed for supporting these innovative services based on valorization of the available data and on new data that might be collected. So this is just an example, and this brings me to the end of my presentation, and thank you very much for the attention. And I think I give the floor to Susanna to present the data lake development. Thank you.
Thank you, Gianmarco. So good morning to everyone. My name is Susana Martin from Fundación Cartif, and during this session I will present the open, federated and enriched data lake that we are developing as part of the DigiBuild project. Sorry. So the agenda for this session, I will present very quickly what is Cartif. Later, I will explain the motivation of the generation of this data lake in the context of the project. Later, I will explain or present the data lake itself. And finally, how this data lake is related to the data lifecycle management process. So very quickly about Cartif, we are a research center, a private non-profit organization. We are located in Valladolid, in more or less in the north of Spain. Our mission is generating technological knowledge and innovative solutions to improve the competitiveness of the companies that we have around. Within the DigiBuild project, the energy division is involved, even we count on different divisions in Cartif, but the energy division is the one involved. And in this energy division, we have more than 50 international, national, and regional projects, 9 of them coordinated projects in the context of the H2020 and Eurasian Europe projects. And particularly, the energy efficiency area is the one involved in the DigiBuild project. So moving to the motivation, why we are creating this data lake in the DigiBuild project. The reason is that we want to move from the traditional silo approaches. I think that part of the challenges that I have represented here in this slide was presented by Stavros at the beginning of the webinar. So the current situation is that we count on building stakeholders that normally have different data needs and use the data in a different manner and with different purposes. We also have buildings that normally are isolated elements and that are not interacting with their occupants, and they are not interacting either with the energy or non-energy systems in the buildings. The data coming from these buildings, if any, normally is not available in one common framework or in one common format. And mainly is due for the lack of interoperability mechanisms in order to access to the elements, the assets existing in the building. Another challenge that we need to cover is the lack of the data quality and accuracy mechanisms in order to guarantee that we are using high quality data for the decision making. And this problem is undermining the decision making and also the investor confidence. And last but not least, we have also the open issue regarding the data protection and security, affecting the accessibility to the energy and non-energy related data. So the approach with the data lake is to move from this silo approach to a digital and high quality data driven smart buildings. That is one of the hot topics also covered by and presented at the beginning of this webinar for the European Commission. And with the smart buildings, we want to offer inclusive environments in order to provide to the stakeholders a knowledge exchange and data exchange environment. Also to be able to count on digitalized buildings, that is buildings that can be monitored and which data can be obtained. And also have this data and information represented in a common format and enriched with contextual information, providing added value or metadata. For all of this, we need the proper interoperability enables for the data integration and exposure. For sure to count on the data quality methodologies applied to the whole life cycle of the data. And finally, to guarantee that the data that we are collecting is secure and protected, and in this case, applying different technologies. So all the bullets represented in this slide are affecting or guiding the development of the DigiBuild data lake. But before jumping to the presentation or explanation of the DigiBuild data lake, I think that is good to present with this data lake in the context of DigiBuild. So we consider a data lake like a centralized repository where structured and unstructured data is stored in any scale or at any scale. The benefits of this data lake is that we can count on this data without any structure, so as is the information, and we can run over this data different type of analytics, as for example, dashboard visualization, real-time analytics, or machine learning and algorithms to guide better the decision-making process. Normally, the data lakes counts on a catalog that is an element indexing the information or the data that is inside the data lake, and that helps to launch a quick search in the data lake. So considering this definition of the data lake, the DigiBuild data lake, sorry, I'm jumping to the next one, sorry. The DigiBuild data lake that we are creating is an open and federated and enriched data lake. Why we consider that the data lake is open is because we are making data available through uniform interfaces to the services, analytics, and computing tools and digital tools available in the upper levels, and also because we are linking the data lake with other open data spaces. We consider this data lake also as federated because we are applying data quality methodologies to support the automatic model checking and also the dynamic checking of the information. In this case, improving the different data quality dimensions in terms of, for example, of completeness, consistency, accuracy, reliability, timeless, and so on and so forth. And finally, we consider the data lake as an enriched element because we are integrating data and metadata from multiple and heterogeneous data sources, and because we are also applying building business intelligence techniques through the generation of different data marts per building domain that are able to combine and link the different information and data that we are collecting from the pilots. So this is the figure presented by Diego at the beginning of the presentation of the DigiBuild project. In this figure, the data lake is this blue part that you can see here, where we're going with the dynamic information. The dynamic time series repository is the core element of the data lake. This dynamic data is linked with the static data and also with the contextual information. And we are providing added value with this information generated in the data maps that are the cubes that you can see here in the middle of the figure. So we are creating data maps per building domain, for example, the thermal energy consumption, the thermal energy, electricity consumption, the SRI, the comfort, the energy performance certificates, and other domains. And we are exposing this information using intelligent querying, not only for the AI-based analytics and the digital building twins that are part of the DigiBuild project, but also for other initiatives, as for example, the digital building logbook or other open data spaces. So how are we creating this data lake? So we are applying different technologies. So the core is the combination of this dynamic time series with the static data. And we are applying the set of technologies that you can see in this slide. So we count on different drivers and connectors in order to assure the connectivity at field level with the different buildings, and also the collection of external data sources that are interesting for the analysis of the pilot, as for example, the weather forecast, the Eurostat, the building stock observatory, and so on. We are applying a blockchain-based data certification for guaranteeing the immutability of the data, not only when collecting the information, so not only during the monitoring of the data, but also the storage of the information in the data lake. We are creating in the data lake ETL modules and processes in order to extract, transform, and load information in the proper format to be used by the high-level services. Also, we are applying data quality checking methods and tools to guarantee the high quality of the information that is in the proper format, that is complete, and that is unique, and so on. In the data lake, we are using semantic data models and ontologies in order to represent the information in a common and a standard data schema. This is also helping the generation of unified interfaces for data exchange. And finally, we are applying the building business intelligence techniques in order to provide added value. That means the information coming from the buildings aggregated, contextualized, enriched, and linked in order to offer to the higher or the upper level analytics only the information that is useful for them. So not all the information, but the per-process information that is useful for the services and analytics in the upper layer. So finally, in the context of the data lake, we need also to guarantee that we cover the whole data lifecycle management process, starting for the data acquisition and passing through the data ingestion, the data integration, where the data quality methodologies are applied. At this point, we are able to obtain the high quality data, and later moving through the data transformation with the ETLs, the data analytics, in this case with the pre-processing or the pre-analytics to the data included in the data lake, the data exposure, and finally the data consumption. So in this sense, we are able to provide high quality data that will be used by high quality services. In order to cover this data lifecycle management process, the data lake need to cover or need to provide 3 levels of interoperability, as mentioned by Diego at the beginning of the DigiBuild presentation. So we need to cover the southbound interoperability that you can find here, that is the part more close to the pilots or to the buildings. And in this sense, we have to move from heterogeneous data samples to homogenized data collection and storage. The northbound interoperability that is in the other side of the data lifecycle process, in this case, being able to expose and share the data that we have in the data lake in a standard and well-defined format. And finally, the semantic interoperability that is, in this case, based on a set of dynamic and adaptable ontologies, for example, Saref and Brick for the dynamic information, and BOT and IFC for the static information. So covering this part and taking in mind my previous slides with all the technologies involved in the data lake, it is the end of my presentation. And I keep at your disposal for any question that you can have. And now I think I pass the floor to my colleague Eliseos that will present the part of the AI-based data-driven services. So the floor is yours. Thank you very much.
Thank you very much, Susanna. Okay, I think I can control the presentation. Okay, so good day, everyone. I'll try to be quick as I think we're quite out of schedule. My name is Eliseos Armas, and I'm research associate at the National Technical University of Athens. Specifically, I'm part of the Decision Support Systems Laboratory, where we focus on applied research and development in the field of information and communication technologies for energy applications. So today, I'm going to present you the toolbox of AI-based data-driven services for built environment that we are developing in the DigiBuild project. I'd like to mention that this work includes some preliminary results of our ongoing efforts in order to contribute to a smarter and more sustainable and more comfortable built environment for all. So I will be introducing you to our toolbox, which is composed of 5 pillars and 15 services and applications that have been developed and are continuously being developed in order to optimize the energy efficiency, comfort, and well-being of occupants in buildings. The first pillar of our toolbox focuses on AI-based services for energy profiling and forecasting, including tools that can identify energy usage patterns and to predict future energy consumption, allowing building operators to better manage their resources and finally reduce costs. Our second pillar is all about data-driven services for energy resource management. These services can help optimize energy consumption and optimally use flexible loads. Moving to our third pillar, we have data-driven energy and non-energy services for enhanced comfort and people well-being. The services were previously presented by Gianmarco as well. This includes tools for optimizing indoor air quality, lighting, or acoustics, among other things. Our fourth pillar is focused on data-driven services for renovation roadmaps, energy efficiency financing in order to help identify areas where energy efficiency improvements can be taking place and provide financing options for building owners looking to make any upgrades to their buildings. While finally, our fifth pillar includes a decision-making tool for under uncertainty conditions in order to help efficient and climate resilient buildings. This includes tools for identifying and mitigating risks associated with climate change and other external factors that can impact the performance of a building. So having said that, our toolbox consists of 15 services and applications, which will be validated in 10 different pilots across Europe. We are confident that these tools are going to help to revolutionize the built environment by improving energy efficiency, by reducing costs, or even by enhancing the comfort and the well-being of the occupants. So I will make a step-by-step presentation of these 5 pillars. First, we have this energy forecasting service, which is an essential tool for building owners and operators who are looking to optimize energy efficiency and enhance comfort in their buildings. So the objective of the energy forecasting is to predict future energy consumption based on historical data. The key objective here is to include some building demand forecasting services, to also forecast flexibility, renewable energy sources, and thermal comfort. So in order to achieve these objectives, we use a variety of tools, including machine learning algorithms, artificial neural networks, transfer learning or incremental learning, in order to allow us to make accurate predictions and optimize energy usage in buildings. I have included here the example of transfer learning. One of the biggest challenges in energy forecasting is dealing with low data quality and data scarcity. So in many cases, there may not be enough historical data available in order to train our models. So as we have some obstacles in order to accurately predict future energy consumption. And this is where transfer learning comes in. So transfer learning is a technique that allows us to leverage knowledge from a related problem domain where there is more data available, and also apply it to a new domain with less data. So in this context, in the context of energy forecasting, transfer learning can be used to build models that can make accurate predictions even when there is limited historical data available. And for example, we can use data from similar buildings in near locations or in other locations, or from industries, in order to train a model and then apply that model to the building in question. So going to the second pillar of services, this pillar focuses on data-driven services for energy resources management, with the aim to optimize energy usage and energy management, especially in scenarios where there is the need to manage flexible loads or district heating systems. So in order to achieve these objectives, we use a variety of tools, including optimization algorithms, heuristic algorithms, or reinforcement learning, which tools allows us to find the optimal solution for a given energy management problem based on the available data we have and the available constraints that we have. So one of the key challenges in this domain is managing flexible loads, as you can see in the slide, such as electrical vehicles or home energy storage systems. The aim here is, by intelligently managing these loads, we must be able to reduce peak demand and avoid the need for costly infrastructure upgrades. So we have the problem of reverse power flow, of energy autonomy, energy autarky. So for example, we can use some optimization algorithms in order to schedule electric vehicles to charge based on the availability of renewable energy sources, either it is a wind park or a photovoltaic, in order to balance the load on a district heating system, or to maximize efficiency and minimize waste, let's say. So in addition to managing flexible loads, we also use data-driven techniques in order to optimize district heating systems, as I said before. We can find the most efficient way to distribute heat to different buildings in a big district heating network based on factors such as temperature, energy demand, or even weather conditions. Finally, we also use these techniques in order to manage mobility. I mentioned earlier electric vehicles and charging stations. So by using techniques such as reinforcement learning, we aim to optimize the scheduling of the charging stations in order to minimize wait times for drivers, and also to reduce the impact on the grid, because as we mentioned, we want to enforce energy autonomy and energy autarky in this context of these smart microgrids. Going to the third pillar, this is about AI-based data-driven services for enhancing comfort and well-being. This group of services has been already introduced by Gianmarco, so I will make just a short reference to that. The aim here is to optimize thermal comfort, basically. So this is critical for ensuring comfort and well-being by using these models and techniques, such as, again, machine learning algorithms and neural networks. We can model and predict the thermal comfort levels in different areas and rooms of the building, and then to adjust heating and cooling systems accordingly in order to maintain these optimal comfort levels. This always has a trade-off on energy consumption. So we want to have these two goals to achieve optimal comfort levels without wasting much energy. So this is the aim of the first service. The second one is about comfort performance contracts, which are some agreements between building owners and occupants in order to provide a certain level of comfort in exchange for a fee. So by using some data to monitor and optimize comfort levels, building owners can provide a higher level of comfort while still reducing energy consumption and costs. Okay, moving to the fourth pillar. This is about using data to develop renovation roadmaps that are based on a catalog of building interventions, and also to provide financing solutions that can help building owners and managers fund such energy efficiency improvements. So we aim here to work on renovation roadmaps which can help the building owner or the manager to make decisions about how to improve the energy efficiency of their buildings by using data to model and predict the performance of different interventions or renovations in buildings. We can help all relevant stakeholders identify the most effective and the most cost-efficient ways to reduce energy consumptions and costs. Another important aspect of this pillar is energy efficiency financing, which can strengthen the funding of energy efficiency improvements. So the aim here is to analyze the cost effectiveness, to evaluate the performance, to assess the economic benefits, and finally to perform energy simulations, to calculate potential savings, and to support managers on how to structure their financing agreements. Finally, our fifth pillar is focused on using data to develop decision-making tools that can help building owners improve the resilience of their buildings in the face of climate change and other uncertainties. A climate-resilient building is a building which is designed and operated to withstand the impact of climate change, such as increased frequency and intensity of extreme weather events, snowing or high temperatures, or changing precipitation patterns. So climate resilient buildings are designed to be more durable, to be more adaptable, and to provide a safe and more comfortable environment for the occupants, even under changing environmental conditions, so they can operate both in high and low temperature. So in this service, we aim to assess the resilience of a building, to put a specific degree of resilience to each building, and also to propose how to reduce the environmental impact of these buildings and to ensure safety and comfort for occupants in the face of these changing conditions. Okay, I think that's all. No, I have one additional slide. Yes, this is the point where I should conclude the presentation of the 5 pillars. However, as we continue to explore emerging trends and research pathways, we have decided to highlight one additional important issue, which is no other than the Smart Readiness Indicator, widely known as SRI to the European Commission. The SRI is a tool developed by the European Commission in order to assess the smart readiness of buildings. So it takes into account many factors, such as energy performance, indoor air quality, and many other factors, and calculates the indicator, the smart readiness indicator of a building. As part of our efforts to promote sustainability and resilience in buildings, we are actively participating in the Commission's efforts to expand the application and the development of the SRI. We are assessing the smart readiness indicator of the DigiBUILD pilot buildings, and we examine the applicability of the SRI in different climate regions across Europe. So in DigiBUILD, we are committed to actively collaborate with other ongoing EU projects and initiatives related to sustainable buildings and energy efficiency as well. So throughout this project, the aim is to answer the question, how ready is each country to apply, and next step to adopt the smart readiness indicator. So I think that's all. We invite you to stay connected, join us on on our efforts to find out and pave the way to a smarter and more sustainable built environment. Would like to thank you, all of you, for your attention, and please feel free to reach out to us if you have any questions or you would like to learn more about our work.
Thank you very much, Lysias, for the presentations, and yeah, thank you to all speakers from both SINEA, from Moderate, and from DigiBUILD for the very interesting presentations. As mentioned before, if there are any questions for the speakers, you can always ask them via chat here directly, and they will try to answer you. Otherwise, what you can also do is you can go to the website of either Moderate or DigiBUILD. You can find the contacts form there, and you can contact the projects if you have any additional questions regarding this. So now I have the pleasure to introduce you, to introduce you to the last parts of our of this webinar. We're running a bit behind schedule, 20 minutes to be exact. So we will continue until 1:20 Brussels time. So to ensure that we have enough time to discuss all the topics for this hugely interesting roundtable. So during this roundtable, I have the pleasure to welcome 4 additional projects, 4 Horizon 2020 projects that work on big data and buildings and the tracking of building performance. Who have been running longer than DigiBUILD and Moderate, and where DigiBUILD and Moderate can also learn from their experiences. So I would welcome all panelists to turn on their cameras. And yeah, so first of all, there's Stojan Danov from the big project that is joining us. Tassos Titsanis from the Beyond project, Ulrich Philippi Obreger from Build Hub, and Dario Pellegrino from Matrix. And then there's, of course, you've seen them before during your presentations, Diego Arnone from DigiBUILD and Christian Pozza from Moderate, who are both the coordinators of DigiBUILD and Moderate. So yeah, let's jump right into it, right? This is the introduction round. I have for the 4 Horizon Europe projects, the 4 Horizon 2020 projects. I have a first question. It's actually one of the more challenging questions. It's in the introduction. So I would ask you if you could briefly introduce your project, and based on what you've heard today and during the discussions, how do you see synergies going further with the newer projects, with the Horizon Europe projects, DigiBUILD and Moderate? And I would ask you if you could limit your answer into 3 minutes. This is the added challenge to it. I'm sorry, we just have to have other topics to go into. So yeah, I'll start with Stojan from the big project. Stojan, if you could introduce big and see how you see further synergies exploring with Moderate and DigiBUILD.
Hello. Well, first to introduce myself, I'm from CIMNE, which is a Center for International Methods for Engineering from Barcelona, and I represent BIG, which is a platform for information aggregation, harmonization, and analytics of big data for buildings. I'm responsible for the harmonization layer, which important part of which is the development of an ontology for big data, which is capable to address well, a variety of use cases along the life cycle of buildings. So with respect to the to the connection with the other projects, I see a lot of synergies there. We are touching different aspects of the buildings or different ways to use the data. So what BIG is focusing on is especially on on developing of highly portable analytics tools and embedded in an architecture that allows these tools to be deployed in different ways, so either locally or at the edge or on cloud. And this is well, the way we approach also the data security and sharing. So there is a freedom to use this in any ways, and this is complemented with highly comprehensive ontology that is capable to address specific use cases, and also a harmonization of data that provides a harmonized input to these analytics tools. So all this is open source, as well the ontology, which will be published soon, and this provides highly open tools that could be reused also by others. So just to mention that, so this data ontology we're developing is highly linked to existing standards, but the aim to create it is to fill existing gaps that that are not allowing the existing ontologies as they are to address our use cases.
Okay, thank you, Stoyan. Yeah, we'll dig into the standardization efforts in a bit. I'll hand over the floor to Tassos for the Beyond project.
Hello, good afternoon. Hope the sound is good. If you can confirm. So, okay, I represent the Beyond project. I'm Tassos Tritsanis from Suite 5. We are an SME, a technology SME located in Cyprus, and we hold the technical coordination of the Beyond project. Very briefly, actually, in Beyond, we bring forward a reference implementation for a big data platform and an analytics toolkit that will stand as the backbone technology for the development on top of them of data-driven and intelligence-enabled applications for the building sector, but also not only the building sector per se. We are not focusing only on the internal energy management optimization, but we are also attempting to introduce buildings as active nodes to the energy system by exposing their data and the intelligence generated by the buildings and the assets that they hold towards thermal networks operators, district heating network operators actually, and electricity grid network operators, in order to collectively, taking into account this knowledge, to collectively optimize operations across the whole energy system. So we are focusing on a holistic approach and a complete data intelligence and service integration across the whole energy system, including the buildings. In this sense, actually, we are investing a lot on the horizontal technologies that will facilitate this integration, meaning the big data platform and the different operations, data operations facilitated through this, together with the analytics toolkit that will provide a bundle of pre-trained analytics along the lines of transfer learning that has been mentioned before, in order to feed intelligence insights in the different applications and services, but also two key aspects that we are focusing on and we are investing a lot and could lead potential synergies with the other projects are, first of all, the interoperability part, the data interoperability part, meaning the way to harmonize and manage the relations between existing standards and not only focusing on their explicit harmonization, but also identifying the standardization gaps and proposing new modeled artifacts towards standardization bodies in order to address all the building assets and all the building data assets actually, and be able to handle seamlessly the information that is generated by them. And on the other hand, we are investing a lot on the data sharing part. We are trying actually to formalize this, because what we have learned actually out of our project is that it's not only making data openly accessible, but you need to promote the sharing and the exchange of this data in a trustful and secure manner, because we are dealing with private data, we are dealing with confidential data, and the data owners have several concerns and several restrictions with regards to the consumers of this data and to the exposure of the data, either on a geographical manner, the geographical boundaries, or even the business boundaries that this data should not overpass. In this sense, and we are introducing a DLT-enabled, a blockchain-enabled mechanism that instructs and facilitates the realization of smart data contracts that adhere to specific access policies and anonymization rules in order to increase trustfulness, first of all, and secondly, increase transparency, because we need also to ensure that data shared across value chains are not misused. And this is a key factor that we need to safeguard in order to encourage building occupants, building managers, and other stakeholders to share their data and make them available for a collective optimization of the building, energy, and mobility sectors together. So this interoperability and data sharing approaches that are introduced in the other projects, together with our approaches, I think could be could set a solid ground actually for further collaboration in the future.
Thank you, Tassos. Indeed, also data sharing, key barrier, which we have the objective to discuss today as well briefly. Ulrich, for BuildHub, the floor is yours.
Yeah, thank you, Jasper. Yeah, hello, welcome to everybody. So I'm a senior researcher in Eurec Research, a private research center in the north of Italy. I'm in the energy efficient buildings group in the team on smart buildings, and I'm recently focusing on occupant behavior towards higher energy efficiency and higher indoor environmental quality, and also smart control for the same purposes. I'm coordinating the BuildHub project, which is currently about in the middle of its lifetime. BuildHub has three main objectives. One is to develop a roadmap for constant data flow to the European Building Stock Observatory. Then also to build a community of stakeholders collecting data on buildings in Europe. And finally, standardized services, which was mentioned a lot today, which are basically standardized services and standardized provision and sharing of data through a web-based platform. Right now, what the project could achieve and will then fine-tune and disseminate and advertise towards the end of the project with basically impact maximization and development of more refined business model, is we have collected several data sets and brought them together in a platform for a different NUTS levels. So a difference with respect to some of the other projects is that we operate at the quite aggregated level, but we collect data for all EU member states. And so the data is typically at NUTS 0 to NUTS 3 level, and possibly also then regional or even municipal level. So with this, we want to provide a standardized way of accessing and bringing together and visualizing and processing, quality checking this data, and then also create therefore knowledge and monitor policies at the EU level, and also define new targets or further revise the existing targets on decarbonizing the building stock. We also analyze in the roadmap possibilities to work together with the EPBD revision, promoting that member states, for example, provide standardized indicators and data about the situation in their national building stocks, so that renovation plans can be better devised. and in the end to give suggestions and to test on our platform approaches for the fairness of data, so findability, accessibility, interoperability, and reusability. And we use several then also technical solutions to achieve this on the platform together with our IT provider, making sure that we can link different data sets by making use of a graph database infrastructure. Thanks.
Thank
I
you.
would pass the floor to Dario then.
Yeah, indeed,
Okay.
Dario from the Matrix
Okay,
project.
good morning. Can you hear me? Yeah. Okay, so good morning. I'm Dario Pellegrino from engineering, and I'm a researcher in the Research and Development Lab of Engineering, and I'm technical coordinator of the Matrix project. So just a few words about the Matrix project. So the Matrix aims to capitalize and combine different and innovative technological solutions based leveraging on artificial intelligence, machine learning, deep learning models, but also big data technologies in order to create different analytics services, different decision-making tools in order to improve the energy efficiency in the building. So I'd like to highlight that in this project, we started from the lack of a specific reference architecture for the building domain. So the first activity and one of the main objective of this project is to define and also implement a reference architecture for building domain that cover different aspects in order to create a big data lake in the building domain, in order to provide data exchange mechanism with secured and trusted data exchange mechanisms, enrich data with semantic annotation and the metadata, guaranteeing also the quality and the accuracy of this data. And this reference architecture provides also a specific layer which include different a platform that can be usable to create and to execute machine learning and deep learning model. And finally, on top of this reference architecture, we have an open cloud-based toolbox, which include different kind of analytics services based on these machine learning and deep learning models, and the data provided by the Matrix data lake. So more or less, I saw several synergies with the whole project in terms of interoperability issues. So an important aspect that we cover also in our project is the integration of data, the data exchange mechanism in an interoperable way. So from the sub-bound interoperability, creating a specific data connector for pilot dataset, but also from external dataset or a European data space. And from Nordbound, for Nordbound interoperability, we have created a specific API and harmonized the data with the common data model based on FIWARE technologies. And finally, also a semantic interoperability with a specific layer which cover the semantic enrichment of data and the visualization of this data in a GraphDB. So more or less, this is what we have done, what we are doing in the Matrix project, the synergies with the other project that we have discussed before.
Thank you, Dario. Well, we've heard from Christian and Diego already regarding the moderate and DigiBuild projects. But so we'll go on to the next topic. And first I will go back to Stoyan as a first question. And Diego, I think you might be able to follow up on this then from DigiBuild's perspective. So the Horizon 2020 projects have worked together have organized actually already a common webinar on standardization of data. I think you've mentioned it as well as yourself that that BIG is trying to address the gaps within the current standards in building data. So from your experience, how do you see that the projects here together around the table, how can they work together on this further, and what has been done so far on it? Can you elaborate more on that, Stoyan?
Well, it is a complex question. I think that we have to continue thinking on how to improve the collaboration. We already did some workshops and exchanges on this, and there are still some other planned for this. We also collaborated apart with these projects with other ones, with Interconnect, which is another big project in this area. And I think that possible line is the interoperability. I think is definitely one issue that is transversal for all the projects, and is let's say the connecting line that could enable also further integration and the exchange of the tools. So there is as I see, there is a variety of different approaches in developing the analytics. So our approach is to containerized analytics, so highly portable way of doing it, and of course security and all these are addressed, but the data sharing, and as I see in moderate project, and so sometimes the data sharing is for real-time management. So in certain cases, synthetic data won't work. So therefore more preliminary analysis or screening of possibilities and services. So our focus is on we have 15 different use cases that cover the whole life cycle of the building. So from first conception of refurbishment to comfort, also integrate with BIM data, so through IFC standards. And I think yeah, definitely one of the collaboration lines is around data models and data standardization and interoperability.
Okay, thank you, Stoyan. So Diego, how do you see that the projects, and what for you are the key barriers to in terms of interoperability for building data from DigiBuild's perspective?
Yes, obviously we have to work a lot to cover the gaps for make everything interoperable. I've seen and heard many opportunities to cooperate with the other projects, many synergies. I think that we should arrange something like a follow-up, since we don't have so much time even offline with this project, because I think that there are really many topics that can be covered, and we can work together in order to overcome these barriers. Since interoperability is an hot topic, and I think that a lot of work must be done on that, but synergies are strictly necessary, and cooperation among the different projects are strictly necessary to overcome these barriers. You know, in different contexts, in different countries, and on the basis of different technologies, we can have several different data models, different services that I've heard that many people mention services, and services, you know, we must evaluate the level of innovations of the services. We must try to understand if the services developed by a project can be used by other projects, if data can be shared, because otherwise we take the risk to develop something that can be considered, let's say, a silo, completely separated from the other initiatives. So this roundtable, in my opinion, can be an opportunity for the next future to start a cooperation also at a lower level. I mean, by putting together also developers that are working on services, for instance, by creating a sort of a community among them that allow us to exchange ideas, to exchange approaches, methodologies, technologies, and so on. So I think that is enough work to do, and enough room to make this collaboration active and to get benefits from this collaboration.
Yes, indeed, it was a very ambitious agenda, quite packed, but I think this roundtable already put an extra good layer on topics that we can discuss further, indeed, and also offline between the projects. I think that would be very valuable. This roundtable could have lasted, I think, 3 times as long as right now, because we couldn't get as in depth into these topics. Christian, maybe because you haven't had the word yet during this roundtable, what's your perspective on the debate and on interoperability? What do you think? How the projects can work further on this? And then, yeah, we're going to have to round up, unfortunately.
Yeah. Well, first of all, I'd like to thank you all the speakers and from the different projects. I think we could we can build on a common ground. In the end, we are targeting more or less the same target users. So I think that there are there's a lot of potential for cooperation. I would start anyway from knowing better the needs or at least to find a way to stick to know in advance or even to share with us and outside the projects which are the emerging needs, because the PBD we saw it's posing a lot of challenges, opportunities also for the market and for other stakeholders. I think we need to understand which they are, how they are changing, and as Diego was mentioning, if we can find a way to reuse and to share both data and services, and to cooperate, to suggest improvements, that would be a very important step for all of us.
Okay, thank you, Christian. So unfortunately, yeah, it is 1:20. We're already 20 minutes over time, and we wanted to get more deep into the topics, but I think there's already established a nice layer of topics that we can talk about further, as mentioned, both offline and in future public events. So I would like to really welcome. I would like to really thank all the projects that could join us in today during the roundtable, and also all the speakers before that. We look further. We look from. I think I can speak on behalf of both DigiBUILD and Moderate side. I will look forward to work together again in the future. Yeah, I wish everyone a great day. The recording will be available on Build Up afterwards. So thank you all.
Thank you.
Thank you.
Thank you very much.
Thank you. Thank you. Bye.
Yeah, bye.
Thank you. Bye-bye.